with me, Miss Miranda. Does anyone know what we are looking at in this photo? Ryan.
I think there is so hot, so it will have some bubble, like when the sun shines to the pond or something. It makes to a cloud, and then the cloud makes rain.
Yep, and you're right, this is the same. This is like a little cloud in the bottle. When it gets hot, the water goes up as a gas, and then when it touches the bottle up here, it cools down. The same way it does in a cloud before it rains. Does anyone know what that's called?
What's the vapor?
Yep, the water vapor. Does anyone know what it's called when the water vapor turns back into water on the side of the bottle? It starts with a C. Pony, go ahead. What do you think it's called?
I think it is changing.
What do you think it is?
Changing.
Not changing. That's a good guess. It starts with a C. When gas vapor turns back into a liquid on the side of the bottle. Thomas?
Chemical change.
Not chemical change, because it's just a change in the state of matter. It's called a new word we're going to learn about on Wednesday, condensation. Just keep it in mind. You've heard it before when you learned about the water cycle. Let's watch some of your cooking videos. First of all, I've already picked which ones to watch. Ben, Leo, Thomas, and Thuy Anh. Excellent job on your videos talking about chemical and physical changes. Alex and Riku, you also talked really, really well about physical and chemical changes by breaking and burning, but it wasn't cooking, which is why I'm not going to show it, but both of your videos were very, very good. So, Thuy Anh, Thomas, Leo, Ben, Alex, and Riku, you will also be getting a star on Class Dojo. Let's start with Ben.
Ben, welcome to my cooking show. Today I will tell you how to make lemonade. These are the materials. The knives, a lemon, a bowl of sugars. Be sweet. A spoon. Let's do this. In the ice is solid. A cup of water. Water is liquid.
So why I picked this one is Ben talked a lot about properties. Who can tell me 3 properties that Ben just said? Riku, what are 3 properties that Ben just said?
Like about solid and liquid.
And can you tell me what he said about the knife or the sugar? Susie, go ahead, Susie.
He said the sugar is sweet.
Excellent. And what did he say about the knife? Do you remember?
He said the knife is sharp.
Very good. All right, let's move on. Don't worry, there will be more questions to answer.
Here, it is physical.
Excellent.
Physical is change shapes or sizes.
Change shape or size. Excellent, Ben.
It's a salt. Then I will put the sugar in. Now we'll mix it. Now this. So that was it is.
I love Ben's energy. He always sounds excited. It makes his videos a lot more fun to watch. So everyone should learn from this And remember, so he talked about properties, he talked about physical change already, and it's exciting. He's tasting things, he's having fun. All right, remember to always try and have a bit of fun in your videos. So that's all we'll watch from that one. Excellent work, Ben. Our next one is Leo. So let's take a look.
Everyone, my name is Leo. Today I will talk about how to make a noodle, and it is a physical change or chemical change. First, I have noodles and boiled water. The noodles is square. It is hard. It is yellow. It is stiff, and it is rough. The water is liquid.
All right. How many properties was that? Did anyone count? Who thinks they knew how many properties? Panda, how many do you think he said?
I guess like 6 or 7 properties.
You're right. Wow, Panda got it on his first try. I counted. Leo just said 6 different properties about his noodles. Nice work, Panda.
It does not have flexibility, texture, hardness, shape, or color.
Talking about the water. Very good.
Gets 100 Celsius. I put the noodles in and wait for it for 2 minutes.
Excellent. The water boils at 100 degrees.
And it is finished. Now the noodles is still solid and the same color, but the hardness, the shape, the texture, and the flexibility change.
How do you guys think the flexibility changed before and after? What do you think? Lion, what do you think?
It has changed. When it is solid, now it is a little bit of liquid.
So how did the flexibility change? Do you think it's more flexible or less flexible after? Thomas, what do you think?
More flexible.
Excellent, exactly.
Now I finished my noodles. It is a chemical change because it cannot be reversible into the square noodles anymore. Bye-bye.
I saw a little oops in there. So yes, it is a chemical change because the molecules have changed. It's not the shape, it's that it cannot become the dry plain noodles again. The noodles will now have the water and all the seasoning and stuff inside of them. It's changed matter. Okay. And Thomas, and then Thuy Anh.
Hello everyone, my name is Thomas. Today I will cook fried eggs. First, I will break the egg. This is a physical change because it's still egg. First, the egg is hard and round, but when I broke it, the yolk is orange and the egg white is yellow. Next, I put it in.
Great observations, Thomas. Very good job talking about the properties of the shell and of the egg yolk and the egg white inside.
I put some cooking oil in. I wait a little bit, then I will put the egg in. Now I'll put the egg in. White is starting turning the color into white. I need to wait more than 30 seconds.
Very good job, Thomas, talking to the camera so that we can see your face. Very good job talking to the camera.
This is a chemical change because
Miss Miranda,
irreversible. I am using heat to changing an egg.
Very good. What did Thomas say he is using to cause the change? What is making the change happen to the egg? Tom, go ahead, Tom. What's making this change happen?
Thomas said heat causes the change to the egg.
Excellent. Very good. Excellent job, Thomas, on talking about what is making the chemical change happen and that it's irreversible. All right. Thomas does talk a good bit more about it, but I want to have time to watch Tui Ang's video as well. So I'm going to stop it there. All right. And the last one is Tui Ang's video. And this one's only 1 minute and 13 seconds, so we can watch the whole thing.
Today I make this again. Today I make pineapple juice. This pineapple is the physical change, and when my mom cut it like this, it becomes physical change because it changes the size and the shape. Now I will make the shape.
All right, how did Tui Ang know that that was a physical change? Let's hear from Kat. Kat, how did she know it was a physical change?
Because she cut the pineapple out, it's still the pineapple.
Excellent, very good. Excellent work. And great job, Tui Ang, talking about the physical change your mom did when she cut it.
Miss Miranda,
Yes, Jack?
any change, its shape, its size.
It's very good, Jack, exactly. Nice work.
Like this, it changes the size and the water is liquid, so it becomes chemical change. Bye.
So this one, the reason I showed this is actually a bit different. So if we look here, this was a good point. You have turned the fruit into a solid and a liquid. You split it into two things, but it is still, making juice is a physical change. You squeeze it, but the juice is still juice and the pineapple is still a pineapple. It's just that the juice came out of the pineapple, but the juice was already in there. And the hard part of the pineapple was already in there. The matter didn't change, you just separated it. Okay? The same way you crack an egg. You have the eggshell and the liquid egg. They used to be together, now they are separate. You crack the egg, you have the eggshell and the liquid egg. They used to be together, now they're separate. For the pineapple juice, you have the solid part of the pineapple and the liquid part of the pineapple. They used to be together, now they are separate. But they still did not change to a different type of matter. after the juice is made, the air, the oxygen, or if you mix sugar and things in, but the oxygen does cause a chemical change to the juice. But making juice is a physical change. You're just squeezing it. The matter is not changing. Does that make sense, everybody? Put a thumbs up, thumb middle, or thumb down about juice being a physical change. Okay, I mostly see upper middle. That's pretty good.
Miss Mara, I have a question.
Yes, Lion?
But what my mom always says is chemical.
Well, the juice does slowly change when it hits the air. The air can make the juice change a little bit. But squeezing the juice out of the fruit is physical. Let's take a look at this orange. Anyone can answer my questions, okay? I won't call on any names. You can answer if you know. When I peel this orange, is this a physical or a chemical change?
Physical change. Physical change.
Okay, very good. Can I please have
Just separated.
Potato, could you tell us why peeling the orange is a physical change?
Because it's still the pin oil.
Excellent. Right? I'm just separating it. Separate. They're not together anymore, just like the eggshell and the egg yolk. So, when I look at this orange, right here, here's my orange slice. This orange is made up of different parts of matter. The orange is made up of the orange skin, and the juice inside. So, when I squeeze it, let me put it here. Okay, when I squeeze this orange to make some juice, there, you can see I have orange juice on my plate now. The juice was already in here. Now I just have the skin here and the juice here. But the juice hasn't changed. Just like the egg yolk, before it was inside, now it's outside. And the skin hasn't changed. Before there was juice inside it, and now it's not. But the skin is still the same. The matter didn't change, it just separates. It goes apart. They're not together anymore. But it's still the same matter, just separated into different parts. Does that make sense?
Yes.
Okay. So, Kuei-Aing, I'm very glad you made that mistake because then we were able to talk about it and learn from it. And the first part of your video about the physical changes was very, very good. Quizzes, let's take a look at your homework. You guys did excellent job. Very good. Okay, I see a lot of 1 attempts and 2 attempts though. Some of you should have really done one more try, okay? The questions that people got wrong the most are 1, 4, 5, 6, 15. 1, I see a lot of people put 14 liters. Megan, this one is math. Lily, could you please read the first one for me? Also, Lily, your video was very, very good with the cooking of the egg and talking about the physical changes. Nice work, Lily. Go ahead and read number 1.
Question.
In each
part, she had 10 toes of battles. What volume of liquid she have stored in all 10 countries?
Excellent. Thank you for reading, Lily. So she has 4 liters of orange juice in each bottle and 10 total bottles. So this one has 4 liters.
I got a question.
Go ahead, Panda. What's your question?
When we know that one bottle has 4 liters and then have total in 10 containers, the easiest way is just like doing a 4 multiply with 10, and then we get 14.
Excellent. I had someone in my other class say that too. I know you guys have learned how to multiply in your Vietnamese class. You can do 4 times 10, or there's 4 liters in each bottle and there's 10 bottles. So 4 groups of 10, 10, 20, 30, 40. 4 groups of 10, or 10 groups of 4. 4, 8, 12, 16, all the way up to 40. Number 2. Measure the mass of an apple. Remember, mass is grams and kilograms. Those of you that put milliliters, liters are for measuring volume. 3, you guys did good. 4, this here cup. A lot of you put liters. Put your hands up in your video. How big is 1 liter? Show me a 1 liter bottle. How big do you think it is? Show me in your video. Use your hands. I see Thomas is doing it. Jack, yeah, I'd say about this big. A liter is about this big. Much bigger. A bottle like this is 1 liter. For example, this is only 390 milliliters. A liter is 1,000 milliliters. It's much bigger than this bottle. If 1 liter is that big, could you measure this glass using liters if liters are this big?
No.
Why? Who can tell me why? Nick, why could we not measure this glass using liters?
If we use liter, it is too small for that cup.
Exactly. The liter is big. The cup is too small. And that's why we use milliliters. This is maybe 300 milliliters.
Question.
A liter, 1 minute, is 1,000 milliliters. So this is not even 1 liter. So we need to use milliliters, okay? Questions, go ahead.
So if we use liter, it is too big, like this.
Exactly. This is only 0.3 liters. It's not even 1 liter. It's less than 1 liter. So that's why we don't want to use liters.
It's more than this.
Exactly. Any other questions? Okay, nice work. 5. Same here, a baseball. Kilograms. A baseball is about, I don't know, not that many grams. It's light. Let's just say it's 100 grams. I'm not sure. That is only 0.1 kilograms. Kilograms, 1 kilogram is 1,000 grams. So again, this baseball is too small. We weigh people in kilograms. Maybe you're 40 kilograms, right? Or 40,000 grams. But something small like this, a baseball, 0.1 kilograms. It's too small for kilograms. We just want to say 100 grams. So just like liters and milliliters, smaller things are grams, bigger things are kilograms. Does that make sense, everybody? All right, guys. So which cup of water has a bigger volume? This one should have been easy. The one on the right has a bigger volume. The water takes up more space. And the other one I said we needed to go over, you use to measure mass. the balance. This one, 16%. This is volume. Other than that, looks pretty good. 15 is the last one I wanted to look at. Which container holds the least volume of water? Least means smallest, right? Those of you that put B, B holds the largest volume of water. That's the opposite, okay? What happens when water is heated? Who can tell me? Let's hear from Jack. Go ahead, Jack.
It turns into gas.
Excellent. Liquid turns into gas. We're going to learn the word for this later. Does anyone already know it?
It turns into water vapor.
Water vapor, excellent. Okay. What happens when a cake is baked? Panda, what happens when a cake is baked?
When a cake is baked, it turns from liquid to solid.
Excellent. And what type of change is that, Panda? Physical or chemical change?
Chemical change.
Good. Chemical change.
Yeah.
And the last one. Can metal turn into a liquid? How? Let's hear from Alex. Alex, can a metal turn into a liquid and how?
No.
No?
Yeah.
A metal cannot turn into a liquid?
Yes. Yes.
How? How could it turn into a liquid?
A hot liquid makes the metal melt.
Okay.
Miss Miranda,
Yes, Jack.
like the acid?
Like acid?
Yes. Acid.
Acid melts things a different way. Acid,
Acid sulfuric.
sulfuric acid will melt things by breaking the molecules. So that's different. Heat melts things by making the molecules move really fast. Acid melts things by breaking the molecules. So it's a little different. Okay. So what do these all have in common? One changes the state of matter. One is a chemical change. This one also changes the state of matter. What do they all have in common? Susie.
They all change the state of matter.
Excellent, very good. They all change state of matter. What else is the same? What is causing this to happen for each of them? Tiger, what causes these to happen?
It's heated.
When it's heated, excellent. Panda asked me a question, is there acid rain and how do we survive? There is acid rain. When pollution goes into the sky, it mixes with the clouds and the liquid and comes down as acid rain. It's bad for the skin. It's bad for the plants and animals. But the acid in the rain is not strong enough to melt your skin or to melt the buildings or anything like that. So the acid rain is bad, yes, but it is not super dangerous, okay? All right, guys, so here we can see, wow, we were very slow today, but we talked about acid, we talked about orange, is juice a physical or chemical change? So, you guys had some great questions today. It just made our class a little slow, but that's okay. I love your questions. So it's all right. Pretty much, this solid to a liquid, everybody say melting.
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 This one is a liquid to a gas. So liquid let me type up here. Liquid water to water vapor. Liquid to a gas. This is called evaporation. Everyone say evaporation.
Evaporation.
Good. You've seen this before when you learned about the water cycle. Water evaporates, turns from a liquid to a gas. Here, this is when the hot gas cools down and it turns from a gas to a liquid. The word for this is condensation. Everyone say condensation.
Condensation.
Good. So the hot gas cools down and turns from a gas to a liquid. That is what happens on your water bottle. That liquid turns into a gas, but it's stuck in here. So when it up here, it cools down, and then you get all the water. Condensation. And we don't have time to do this little experiment, maybe tomorrow. Everyone, go ahead and draw. Let's see what you remember from what I just said. Nice work. There's a few people that disagree, but for the most part, we see this is melting. This one, the water is evaporating, turning into a gas. And this one, the gas is condensing. The gas is turning into a liquid.
I know why, because
Today we learned, everybody read number 1. Everyone, read number 1. Excellent. Everyone read number 2. Excellent. And everyone read number 3 about condensation. Excellent. And homework is to learn at home. What can you figure out on your own? You're going to watch this video about changes of state. Your mom and dad will get this video link in their email, okay? It tells you to pause. Pause also means stop. So it tells you to stop or pause 2 times during the video and fill something in. That is your homework. So watch the video and pause it 2 times. Both times, draw a quick picture and fill in the blanks. After, you can press play and check your answer. So try it on your own first. Here's the first one. This will pop up and the video will say, pause the video and try on your own. So you'll stop it. You will draw this quickly. Draw a quick picture and then fill in the blank. Then you'll see this one. It'll say pause the video and try on your own. So you'll draw this and then fill it in. All right? And then you'll press play to check your answer. But try on your own first. So this is what the 2 screens look like. You will have 2 drawings and you will fill in all the blanks. Okay, I will see you all tomorrow. Have a great day, everybody. Bye-bye.